Weight and balance limits for any aircraft must be taken into consideration as it is critical to flight safety. Flying with the centre of gravity outside the approved limits results in control difficulty of an aircraft. Also, if the weight is greater than the lift generated, the aircraft may be incapable of flight.
It is important to calculate an aircraft's takeoff weight prior to takeoff to ensure that it can leave the ground and fly safely. Excessive weight can reduce flight performance. An overloaded aircraft would undertake a longer takeoff run and landing run. Other such dangers are a higher stalling speed, reduced rate and angle of climb, and a shorter range in flight. To prevent these risks from occurring, pre-flight planning should include a check of the aircraft's performing charts.
Balance refers to the location of the centre of gravity of an aircraft. It is vital for stability and safety in flight. The centre of gravity is a point at which an aircraft would balance if it were suspended at that point. However, the centre of gravity is not a fixed point, and its location can depend on weight distribution in an aircraft. The aircraft's manufacturer determines the limits for the location of the centre of gravity along the longitudinal axis of the aircraft. In order to stay within the limits and to balance the aircraft, it is advised to shift the weight, such as moving baggage and cargo, or assigning passengers to different seats. To avoid lateral unbalance of an aircraft, make sure to supply the engine or engines evenly from the tanks on the airplane, preventing a wing-heavy condition.
There are three different methods for determining the loaded weight and the centre of gravity of an aircraft. There is the computational method and as well as the graph and table method, which is provided by the aircraft manufacturer. To determine the centre of gravity using the computational method, you must first list the weight of the aircraft, occupants, baggage and aviation fuel. Calculate the moment for each item by multiplying weight by arm. Find the total weight and total moment, then divide that total moment by the total weight to determine the centre of gravity. The same steps apply for the graph method, but it will provide calculations of the moments and enable a pilot to determine if the aircraft is landed within limits. Same goes for the calculations of the table method, but the information and limitations are contained in tables provided by the aircraft manufacturer.
As previously discussed, calculating the centre of gravity of an aircraft and keeping it within the limits is vital for a safe, balanced flight. If not kept within the specified limits, there is a danger of decreased performance and control difficulty. It may also increase pilot fatigue, having to use excessive trim, which would reduce aerodynamic efficiency. If the centre of gravity of an aircraft is too far forward, nose-heavy condition can occur. The danger of this results in the difficulty of an aircraft to flare for landing and may nose over for tailwheel type airplanes. Problems such as higher stalling speeds, higher control forces, difficulty controlling and raising the nose can happen. If the centre of gravity of an aircraft is too far aft, tail-heavy condition may occur. This leads to a serious effect on longitudinal stability of an aircraft and reduces capability to recover from stalls and spins. It can also produce very light control forces which can unintentionally overstress an aircraft.